Okay, so we're talking about functions. First thing I want you to remember is essentially when the last lesson we talked about, we had the groups, right? We did this, we did that. We said here's our x, you jump on the function, and you get your f of x. So this is my domain, here's my range, which basically our domain, here's our x, our range is our y value, right? So essentially y is equal to f of x, okay? So if I give you an equation, f of x is equal to 2x plus 1. Now the purpose for using the f of x is sometimes you want to know exactly at a certain time, a particular moment. You're not interested in the whole story. It's like, you might say to your girlfriend, hey, how was lunch? And she says, hey, I woke up this morning and I was really happy because I woke up and my alarm was going off and I had a good dream. I turned it on and then I got up and my clothes, I didn't have to iron them. And she's telling you this, so on and so forth. And then she's talking about how she had cereal for breakfast and they were really good. And you don't care about all that. You're like, hey, how was your lunch? You don't want to hear all the stuff that goes with it. Well, this is what f of x does. Because f of x is saying, hey, if I say, how was your day at 3 o'clock? Right? What I'm saying is, the only thing I'm interested in is when x is 3. So I'm going to switch this up. I'm going to say, hey, 2, 3 plus 1. Notice, this is a linear equation. I'm not asking what this line behaves like. I know it's a line. I don't really care that it's a line. What I want to know is, at 3, what's going on? So this becomes 6 plus 1, which is 7. So what this means is, when x is equal to 3, then y is equal to 7. That's what this statement means. All right? We're getting right to it. We're not worried about anything else except for this area, these points. All right? Now, if I want to ask you where the domain, that means I'm asking you what are all the x's that can be used. So, if I got f of x is equal to the square root of x minus 3, I say what's the domain? Translation. What are all the x's that I can use? So if I think about it, and I'm just going to pick like a random number. Notice at f of 1, this becomes 1 minus 3. Alright, now here's the deal. At this point it's negative. So I know this is an imaginary number. I'm not interested in imaginary numbers. Not on our coordinate plane system. What I'm looking for are real numbers. So what I'm going to have to do is I'm going to have to realize that when I have a square root, my square root of 0 is 0. Once it becomes negative, I'm in the imaginary zone. That's not where I want to be. I just want to stay with the reals right now. So it's got to be bigger than 0. So whatever x is, my x has got to be to where this, right here, my x minus 3 is going to be at least 0. So to set this up, x minus 3 has got to be at least. At least means greater than or equal to. I add 3 both sides. X is greater or equal to 3. And this makes sense to me because f of 3 is equal to 3 minus 3. F of 3 is equal to square root of 0. F of 3 is equal to 0. So I know that when x is 3, my y is 0. If I wanted to use a 4, a 5, a 6, a 10, a 50,000, whatever it is, I can use that. But x has got to be greater than 3, or greater than 0, so x is going to be 3. So here's the deal. 1, 2, 3. When x is 3, y is 0. Just like that. If I stick in a 4, f of 4 becomes 4 minus 3, which is the square root of 1, which is 1. So when x is 4, y is 1. Just like that. And so what we're going to have, this is going to start going off and going like this. Right? Our square root. Good to go? Now, so when I ask for the domain, I'm going to say that my domain is the set of all real numbers such that x is greater or equal to 3. Right? Another way to do this is just to say the domain is from 3 to infinity. Notice the bracket because it's equal to 3 and then it goes on all the way to infinity. All right, now here's the deal. Whenever we have a 0 in the denominator, whenever I have a 0 in my denominator, my equation is going to be undefined. So essentially what I'm looking for, since I have a denominator here, I'm in a situation where I got to make sure my equation is not undefined. So I'm going to set my denominator equal to 0. So now my x minus 3 is going to be equal to 0. So I add 3 to both sides, so I say x is equal to 3. So what this means is, when x is 3, if I plug this in, f of 3 is equal to 15, 3 minus 3. So this is going to be 0. So when x is 3, my y is undefined. So I know that 1, 2, 3, I'm going to have a hole. There's going to be a big void right here at the 3, to where it can be anything but 3. That cannot be 3. So essentially my domain is going to be the set of all real numbers such that x does not equal to 3. Just like that. Now, if you'd like to put that in interval notation, we would say negative infinity to 3. Notice my parentheses, meaning that 3 is not being included. U, 3 to infinity. That's another way to put it like this for my domain. All right? And now, for this one, notice that I don't have any square roots. So I don't have to worry about imaginary numbers. My denominator is 1. I have no variables in my denominator. And because of that, I know I don't have to worry about it being undefined. So for this one here, I'm going to say my domain is the set of all real numbers. Or I could say the domain is from negative infinity to positive infinity. Now even if g of x is equal to x squared plus 16x plus 4 all over 34. Notice that this is a constant, no variables. So again, it would be all real numbers. All right, so here's what I'm looking at. On this one, there's two parts that I'm thinking. First of all, I got something in my denominator. So I know that my denominator is going to have issues, since I got a variable in here, so there's going to be somewhere where it's undefined. I also got a radical going on. So because I got this radical, I also have to think about, what can this be in order to stay with that. So what I'm going to do is I'm going to go ahead, I'm going to set this equal to 0. So I'm going to say x, square root of x minus 2 is equal to 0. I add 2 to both sides. Square root of x is equal to 2. To get rid of the square root, I'm going to go ahead, I'm going to take the square of it. So I'm going to square it. All right? So x is equal to 4. Now this is going to make sense. Because notice if I put a 4 in here, if k of x, or k of 4, is going to be equal to 2, square root of 4 minus 2, which becomes 2 minus 2, which is our undefined. Right? So I know that x cannot be equal to 4. However, x also has to be what? Has to be positive. It's got to be positive, because if I have any x's that are negative, then this is going to become imaginary, right? Then we're going to have a complex number, which is going to involve our imaginary and a real number. And that's not what we want. So, for my domain, I want you to see that essentially what we're doing, we're saying we're going to go from, we can use 0. So we can say 0 all the way until almost 4. Notice the parenthesis on 4. Then we're jumping over the 4, and we're going all the way until infinity. So here's our domain for this. All right? So with this, x is going to be positive, and it can't be 4. Because if you look at this, if this was 1, well, the square root of 1 is 1, right? 1 minus 2, negative 1. And 2 divided by negative 1, negative 2. We still have a good value. All right? So these are our intros to our functions or whatnot. Smile, maybe wake up, I don't know. Whatever you want to do.